Hello, guys and girls. Welcome all of you to Global Coding Cohort. This is Lekshman here. I hope all of you are doing very well. In this session, we are going to solve the path finding problem. This is the problem statement. So our task is to print if there is a path to connect 2 points in the given maze of size 5 into 5. That means this size is going to be fixed. Okay, 5 column, 5 row. Going to be fixed. It will not change. Okay, then wherever dot is there, then it means there is a path. That is a path. Okay. So hash means it's wall. So wherever hash is present, you cannot break that and walk. So that's its meaning. Wherever a wall is there, you cannot go after that. So 2 points mentioned there. In a statement we have mentioned there are 2 points. Isn't it? So those are this first 0, comma 0. We are going to consider this as a matrix. Okay. So first 0, comma 0. This is the starting point, and this is 4, comma 4. This is the ending point. And both these places should not be uh, wall at any time. It should always have dot at these two places at starting and ending. Okay, and then in this maze, other than this dot and hash, no other symbol should be used. Only this dot and hash should be used while we give our input. You can take input in the form of matrix also. Matrix, okay. In any way you can take, but for this session, I'll be taking input as matrix. And you want to beautifully print it here over here. I will convert that to a string also. So you shortly. Or let me explain that. Uh, okay. I think the string is not visible. Only partially it's visible. It's its own. Okay. This way. I hope to solve this the problem statement. The task is to print if there is a path exists between 2 points. And the 2 points are this. This is 0, comma 0. This is 4, comma 4. These are the starting and ending points. 0, comma 0 is the starting point, and 4, comma 4 is the ending point. Okay. And then uh, dot means there is a path. Hash means it is wall. We cannot break it and move ahead. Okay. So then, okay, only dot or hash should be present on the input. No other symbol is allowed. Next, compulsorily there should be a dot at both ending and starting point. We can take input in any form, but in this session I will be taking input as matrix. Now first input we have dot 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 Instead of hash, I'm going to mark it as X. Okay, just for you. Business dot. So in this input, we have a path. That means go this way, here, then go this way. There is a path, isn't fine. This horizontal line is not straight, but this is the path. Okay, just drawn to show you this is the path. Somewhere there is a setting. Okay, from the next session I will it so that's straight from the path. So here in this example we have a path. We have to print path found. In our second example, here itself I can show you that this is the starting point. There is no way at all. It is completely closed. It can either be like this also, or in some other places there can be any block. That means path might come till here, but after that, if it even if it is one step ahead of our ending point, if it cannot reach, then there is no path. Okay, we have to consider like that. Different path not found. Okay, I hope all of you understood the problem statement. Let's solve it. So for this question, sorry, generate. I'm not going to manually give this input because there are a lot of test cases. I cannot sit and type this one by one. So I'm going to generate it randomly. Use as matrix. Okay. I'm going to uh, because one more. I'm adding two dots because when it is one dot and one hash, then there are chances 50% of the time, 50%, not more than even 50% of the time, you will get uh, a matrix with no path. Okay, so that's why I'm adding uh, two dots so that there are more chances for the matrix to have a path between the source and destination. Okay, then sorry, two for that going to pass the n. N means fixed, isn't it? That means n by n, 5 by 5. That is what I'm taking as n. So this is our. So to beautifully print it, uh, while you print it, we have to present it beautifully, isn't it? Here, somewhat not that good, isn't it? I'm going to convert this maze to n else Then this scenario, I'm just going to stringify it. I the space in between is then the, there should be a dot compulsory reason. There may not be any dot sometimes. So see in this case, previously in our first input itself, there are hash in our source and destination. We have to replace that with the dot is in. So that's why this condition is written. We are generating our input, okay, instead of like so that I have random number of tests. N number of random test cases, okay. Then after each row, I want to get the cover time. Around get it 0, 0, comma 1 itself. Oh, sorry, not maze time. Okay, it is maze. It should be maze. So where is where our input generated matrix is percentage. Now, now it's beautifully printed. See, compare this, which is good. Obviously, this string maze is within Buddhism. So that's why we created it on so that we can easily check if there is a path, verify if our output is right or wrong. So each step will get into maze generated. But it may have path or not. We have to find it. Okay, that is our task. This just for our manual understanding this maze thing. But in our solution, we will be using our original maze matrix. Okay, this one. I'm planning to recursively solve this problem. So instead of giving a name, instead of giving find if the path is not, I'm going to give a name called uh, get target. So that at each recursion it will try to check whether that current value is our target. So now we are currently initially will be standing here, isn't it? Starting point is this. So now I'm going to give a default of 0. Always when it starts, by default it will start from the 0, 0. Okay. So initially to find the solution to it, let's start with this maze will not have a path, isn't it? It stores and destination. This is our destination. So storage stores isn't. So between this we do not have a path because there are walls in between. So let's start. Let's generate its particular path. Okay. This maze we have a path. There are a number of paths. Our task is just to find if there is a path exist or not. So in this maze we have a path. So we will try to build our solution with this input. To pass this input value that can set up to I and j. Okay, so set this. Okay, in the initial step, we know that our starting tuple is not our destination step. So, but however, this function is going to be used recursively. So therefore, we are going to start with this condition. Okay, whether we are going to check whether the current input value is our destination or not. So as our maze is going to be fixed size 5 into 5, we are going to check if that is our destination with if statement. Okay, we are going to see path found. We are going to print design. So okay, we will handle that later. Let us just have print as of now. We need to create it. We will do it later. Okay. Path. there is a small tweaking in our problem statement. Okay, there is no path. We will not print anything. We'll just leave it. Okay, this session we are not planning to. Uh, I'm not planning to return to handle it, but we will try to use this solution tomorrow to achieve another task. Okay, this is a part of a bigger problem. I have split it into a small problem so that I can finish it within the time limit. So for today's session, we will go like this. Okay, today we are just going to find if there is a path exists or not. That's what we are going to find today. If not, if this is not the destination, then what has been okay? Here we have four directions. For first one, it just has only two ways. One is this east, another is right. So north, south. These are the four directions in which we can move. Okay, at any point. But from this border in this borderlines and in this initial and ending point, we do not have four directions. We only just have two directions. Especially in this particular input, we just have only one direction. Okay, but generally, for example, uh, for this for this location, we have four paths. So that's why we are going to proceed in that way, considering there are four paths. Okay. If not, it will not move. That's it. Um, okay. I'm going to calculate the next position. Okay. So rho is managed by I. Okay. If I am going to move move upward, then I minus one. For south, it's downwards, downward direction. So I plus one. For east, A plus one. West, A minus one. This maze is a global variable. It can be accessed within the functional code. Okay, before that, you have to check uh, is not uh, greater than or equal to 0. Beyond that, it should not go, isn't it? So similarly, for other things also, you have to check south, south, just an n. N is also a global variable, and for east, it's less than 10. And for this, so it is not equal to 2. So if this is satisfied, then we have to found that there is that the value that is present in that location is not big. Uh, North isn't. North JDP, not is not big. It is what is given by this hash. Okay. Uh, so similarly for other things also, I will confirm that. I will edit it. Okay. So with appropriate values, route comes in. That means in the same row, but in this direction comes this row list. The reason why we gave J here means in the same column it is going to go, it's either going upward or downward. Okay. Then not these else part get executed only if it is not a destination. Okay. So that means we are still away from, that means we are still away from our destination. We are not on destination. Okay. So that's what we are checking if that next point is uh, that's why we are checking if our next point is a wall or not. Then uh, next point we should check if it is not visited or not. The reason why we are checking means just check this example. Uh, while we recursively check at this point, just assume we are at this point. Okay. From here, we will also go here. Isn't sometimes it may be already visited. If we do not check if it is already visited or not, for this it can again go back and go here. From here we have four directions to move. But when we other direction it's fine, no problem. But when we go back, and this will happen for all other location also. There are chances we can loop repeatedly. To avoid that, we are going to check. We just need to check if there is a path or not, isn't it? We are going to have a way called right? Okay. This point sorry, not I, it is J. Okay. Equal to comma rest. One of our viewers have commented All this. Okay, thank you, Shan. Point nine visited in Noel. This is common for all. That for all. Then if not visited, we have to move ahead. Isn't it? So move ahead means I'm going to call in this check target. If not, from that point also it is again going to check. So the recursion happens that way. Now, so the current point is next. The new now is next point, isn't it? So that's why I'm going passing it over there. Visited. If you miss anything, we will fix it. Okay. We will run this code and check if it's working or not. So for our current input, this is going to be executed for this particular input. Okay. For this, we have a path. Let's check. It is a recursion error. That means running for a more number of times. That means we have logically made some error there. We have fixed that. Okay, I got it. We have to make because other recursion functions do not know whether the path is found or not. It might keep looping, isn't it? So that's why it happens. Logical error happens. We have to path point a variable called path point. So now it will run. The new variables will stop from generating if path is found. Okay. So it should run only till it is false. Otherwise, it should not. That means path equal to from. Let's check. So still we face this error. Oh, sorry. We did for visited, we wrote. If it is not visited, then we have to pass. But if visited, we have not made any change. We have to add that to the visited decision. But we have not done that. So this is right. I hope because of that is the main reason. Yes, right. Let's now just simply can see. That means it's visiting, isn't it? No problem. No, no, no. Before checking it, before we split our input value itself, we just pass that input variable now by it the path found. Let's check with other call this same function. Yes, okay. Just for the time being, I will copy that. But make sure that this cell is executed before this line is executed. Okay. So I'm going to generate the new. So let's manually check if there is a path. So there is a path. So transform path found. Else it will return nothing. Okay. Here it has no path or blocked. So there is no path to reach this particular destination from this starting point. Okay. So there it has not returned anything. Check for different output. Uh, okay, it has do not have a path. Let's check. So it's not printing anything. It has a path. It has many paths, but still it is not printed. Isn't it? So where is it going wrong? Let's check it. Path found. Oh, sorry. This okay. Okay. This is not getting executed over there. That's why that error. I think. Let's paste it here. Because those are global variables. Isn't it? We missed it. So path found. Okay, no way to reach the destination. We expect to have and nothing. Another. Okay, do we have path? Do we have path? Yes, we have path. Expected is path found. Correct. We do not have. We have a path. We have a path. We have a path. Path found. So this. We yeah. We have a path. Path found. We do not have a path. So expecting it to print nothing. So it's correct. Now we will check for some other no path testing. Okay. So that's why to generate more no path input, taking that additional dot from there. There's no path, expected path, no path, no path, no path. That's why this is what the difference which I mentioned at first. When we remove that, most of the thing will be no path. That's why we added uh, additional dot over there to generate input with path. So now it got generated. So now and more number of time input with path will be generated. Okay. So I hope you enjoyed this session. I hope all of you understood this solution. So we'll continue. This is a chunk of a bigger problem. Okay. So we have done with our initial step of finding whether there is a path or not. In the upcoming sessions, we may continue. We will uh, use this code and we'll proceed with the next step of task. Okay. So that's it for today's session. Uh, Please make sure to like share a few words about this live coding session to your friends and colleagues. It will help them clear their coding count of interview because I'm introducing you different ways. Uh, the main objective of me is to uh, expose the way how I think. So that's why I'm instead of writing a code before live session, I'm writing during the live so that you can understand how I am thinking and how I am fixing the bugs. So when you get introduced to when you get introduced to a lot of ways like this, then while you solve a problem, you can think like this and solve it. Isn't it? Will be comparatively easy. So that's why this live code session is. Uh, so meet you with another problem tomorrow. Until then, bye bye.